Hello and good morning and good afternoon, depending on where you are. This is Monica Paolini from Sensafili, and today I have the pleasure to talk to Peter Claydon, who is the president of Picocom. And what we're talking today about is Open RAN. And we're talking about the big picture Open RAN. Open RAN is more than the interface, the front hall interface. There is way more to it, and today we're going to talk about the silicon part of it. So, Peter, thanks a lot, so much for taking the time to talk to us.
Thank you, Monica.
So, well, first of all, let's get started. And if you can tell us, what is it you do at Picocom, and how does it relate to the Open RAN ecosystem?
Well, Picocom's a semiconductor company, and we develop chips for 4G, 5G infrastructure, specifically small cell, but it goes a bit beyond that. And also specifically for Open RAN. And when we say Open RAN, it's kind of the broader, it's not just front hall interface, which is something we do. The interface between the layer 1 and layer 2, the FAPI interface, which is defined by a small cell form, is very important to us as well, as are other interfaces.
Yes. So can you tell us how does the FAPI interface how is it related to the Open RAN? Just quickly.
Well, yes, Open RAN, I mean, there are lots of different components to it, and our chips implement the PHY layer, layer 1, and that can be part of a integrated base station small cell, GNO-B. The upper PHY forms part of an ODU, a distributed unit, and the lower PHY forms part of an ORU, the radio unit. But the interface between layer 1 and layer 2 is being standardized basically since back in 4G days. There's this interface called FAPI. Now, that interface is important because the layer 1 is generally provided by semiconductor companies such as Picocom or Qualcomm or Marvell. And the layer 2 and layer 3 is provided by other companies such as Radiosys. So it's important when someone's developing a product that they can actually get those different components from different vendors and put them together. So although that's not an interface, it generally appears between different units. It's very important as part of Open RAN. And in fact, in its form of NFAPI, network FAPI, it can be the interface between two units in a split SIG system.
Thanks. So, we're talking about semiconductors here, but when you think about Open RAN, the main idea, the main proposition is that you can pick and choose whatever off the shelf. So why is it different, or can we do that with at the semiconductor level as well?
Yes, I mean, there are a variety of vendors. I just mentioned the three main ones there of semiconductor devices in all targeting Open RAN. So it's important in any ecosystem to have a choice, a variety of things. I think, in the early days of Open RAN, people looked at, we're going to do everything in software, and we're going to use off-the-shelf, custom off-the-shelf servers, computers, buy complete servers and install software on those. And fundamentally, that doesn't work because there's some things that actually needs custom hardware. I mean, the obvious bit, the closer to the antenna you get, the antenna itself and everything that's closely associated with it is obviously custom hardware. It's not software. And in actual fact, a lot of the layer 1, the physical layer, you do need some, it's implemented in silicon, but it's something that in many cases, you can't actually do at all on a standard processor. So it's important, there's always some element of silicon devices in there that are specific for Open RAN. And that might be, there is a trade-off. There is a trade-off, and that's very important. Some things you want to be soft, you want to be configurable, and other things, they don't need to be so configurable. And if they were soft, you'd be burning, dozens of cores on a server. So you don't really want to be doing that either from a cost or power point of view.
Yes, so there seem to be a lot of trade-offs, and in general, this is regardless of what you're talking about, the more customized, the better the hardware, software it is, it's going to be better, but that also kind of constrains you in different ways. Or it might be more expensive, or you might have less choice. So how does an operator look into this? You mentioned already some of the trade-offs. Maybe you can tell us a little bit more about how do you choose between the two?
Well, I mean, I think there are factors there. There's one thing is silicon area, and I had this figure I worked out that silicon costs $200 billion per square mile, and that goes down to a 12-inch silicon wafer costing, I don't know, $5,000 or $6,000 or something, which is roughly in the ballpark. So regardless what you're building, you have that underlying cost, what it costs if you go to TSMC or Samsung, or what it costs Intel to make silicon, and they've got to package it and test it as well. But if you've got something that's optimized for the application, you've actually said, okay, I'm going to build whatever it is on silicon in a way which is specific for that, so you're not wasting in the area. Whereas if something's general purpose, it has been a lot more flexible. So, if you go to the limit, if you've got, cores on a server, they've got to do all sorts of different things. They have, hundreds or thousands of variations of different instructions. They have big caches, buses. So there's a lot of extra area there, which is required for some applications, not for others. So if you've got a specific application, you can always get to a smaller silicon area. So if nothing was ever going to change, you just build it out of hardware and you have a very small chip. The key is to actually figuring out what bits of it need to be soft, what you need to be able to program, what you need to be able to change, and what you can actually make small. And small is not just low cost because it's low silicon area, it's low power, which is very important as well.
Yes, and so flexibility seems to be here the main value that you want to have, hit the right amount of flexibility and performance, combined with performance. So does it mean that an operator comes to you and say, this is what we need, or through a vendor or whatever, but so is it going to be, are you able to have a chipset that is specifically designed for an operator, for a vendor, for a set of vendors? How much, I guess my question is, how much detailed can you be?
Yes, I mean, I guess it's it's types of applications. So I said at the beginning we were focused on small cells, and I think in 5G especially, you've got this difference between massive MIMO. So 60/40, 64R, the antennas have been forming, and that's in terms of what you do in silicon. Whether it's optimized or not optimized, you've got some big matrix arithmetic you're doing there, and that takes up a lot of silicon area. In small cells, that side of the thing tends to crunch down into something that's a lot smaller. So we've focused on cells that are really 8T, 8R or less, or it could be 4 lots of 2T, 2R, for example, on the same silicon. And that's the area that we've optimized in on. So we're not focused on those massive MIMO antennas. I mean, that said, you could still, when we say small cell, we could still deal with say a rural macro cell that had 8 antennas in its quite happily. The processing is kind of largely the same, but that's the optimization we've done. So if you try to take something that's designed for massive MIMO and use it in a small cell situation, it's very difficult. You've got there's lots of stuff there that you don't need in a small cell.
Absolutely. And so why did you pick small cells? I mean, is that what you hear in terms of, is that's more of a need or more of a market? What's the reason there?
Yes, I mean, one thing is it's because if you look at the big vendors, Nokia, Ericsson, Huawei, they focused initially on massive MIMO and macro cells, and that's their area of focus. And if you look at the history, if you go back to 4G, the macro cell deployment started, say, in 2010. Operators focused on building up that macro coverage, And then a few years later, really only about 2014, did the small cell market really start to come in and people started to put in more infill in building coverage. And you can see the same actually happen in 5G. The operators are focused on their macro build out. Small cells are coming on later. I mean, we think the market's going to start taking off more likely in 2023, 24. And there are actually a lot more small cells ultimately than there are macro cells. And it's an area we can get in, we can enable alternative vendors, and alternative vendors in the 5G era, that's really all about people who are implementing Open RAN.
Yes, some people sort of assume that Open RAN is like, it's a macro thing. You don't, small cells, you don't need Open RAN. And I guess you have a different view on that.
Yes, I mean, I think it's when you get massive complexity in the RAN, and there's complexity for various reasons. 5G is very flexible, a lot more so than 4G. Lots of different types of application. And so you get a lot of vendors there. I mean, even in 4G, there were different vendors, say for layer 1 and layer 2. When you go to the silicon level, there's the RF front end, there are transceivers, there's baseband. So there are a lot of different things that come together, and it's difficult for any of those to compete if you're having to have proprietary interfaces between all the different parts of that. That might make life very difficult, and it's not an area that any of us want to compete on. So we cooperate with other silicon vendors to try and get common interfaces that we've agreed on, and then we can compete in either, maybe directly in some cases or in different market areas, but based around those same interfaces. And it is the same with any market. We all use Wi-Fi, standardized Wi-Fi on our laptops to communicate with the network. That's not anything anyone wants to compete on when they're making a laptop.
Yes, so we're going to go to the interfaces in a minute, but let me ask you first, in terms of small cells, a big potential market is going to be private networks. And I think it's actually very good for Open RAN, but not everybody agrees. What's your view on the opportunity and the benefits of Open RAN in private networks, which I guess, especially for indoor coverage, is going to be pretty much all small cells?
Yes, it's interesting. I think at the moment, actually on private networks, people are still mainly deploying 4G, and in some cases, some initial deployments in 5G will be integrated GNOBs rather than a kind of disaggregated Open RAN. But we're certainly seeing that our customers are all kind of moving towards Open RAN, and it does enable them to kind of give that that element of choice, that you can choose the best thing for each part of the network. So your central units, your distributed units, and your radio units, and sometimes those are integrated where it makes sense, and sometimes not. So that combination of overall cost and indeed performance, and performance part of it is about being able to the layer 2, your scheduler, being able to look across lots of radios and optimize the network to get the best experience and the best throughput across those, which is something that Open RAN deployments allow you to do at the same time as having the appropriate level of performance for each component.
Absolutely. Okay, so let's talk about the interfaces and interoperability, because that is a really key differentiator in terms of Open RAN. You're able to mix and match to some extent. In theory, to any extent, but we're not there yet. So, okay, maybe we can start. What is the work that you're doing in that area to make sure that your solutions work with everybody else, and to make sure that the whole ecosystem develops to a point where it's possible? Because clearly that's something where if everybody has to be able to work together. And you mentioned you working with other chipset vendors. So how is that? Where is it happening? What is happening there? And what you're doing?
Yes, I think if you look at like lots of mature systems, ecosystems, what you actually find is that kind of at the bottom, you have probably a relatively small number of semiconductor companies and a small number of test equipment companies. And then you may have a whole host of other vendors on top of that. I mean, that would certainly happen, say, with a Wi-Fi access point, or, Ethernet routers. They're all based on, say, a lot of them based on Broadcom silicon. So they're all using the same silicon underneath, and they're using the same test equipment. And that's what we're seeing beginning to happen now in the Open RAN. So we have the test equipment vendors. They're bringing equipment that tests all these interfaces. You've got a small number of silicon vendors who are building sometimes complete reference designs based on those. And then you move from those to a large number of vendors. And those vendors, because they're basing their solutions on the same underlying technology, and they're differentiating sometimes technologically, sometimes because the access they have to specific market segments, but they don't have to be reinventing the wheel all the time. They can take a semiconductor company's reference design. That means that the silicon might be pre-integrated with software from one layer 2 vendor or several layer 2 vendors, and it gets built up on top of that. And that's what's really going to drive, the uptake of Open RAN. We're not really there yet, and I think that's why we're seeing all this. That I don't know where Open RAN is in the hype curve. It's probably kind of gone over the top now. We're seeing some quite a bit of negative press, but as we get to that integration, and we'll start to see it develop. And you mentioned, I mean, we do work with other semiconductor companies. We work with them in, say, the Small Cell Forum and in the ORAN Alliance, and we all contribute to the same specifications, and people have input, and we're seeing a very constructive process going on there, with input being taken, across from a number of vendors, and those are tending to be driven, in fact, by the semiconductor companies rather than other people.
Yeah, absolutely. No, Sal, you said that we're not quite there yet. Can you tell us where are we in the, the ideal target is that everything works with everything else, right? And again, we might never get there, really. And I think that's a reason, because you have different vendors that are better than others. So you should not have that kind of necessarily everybody. But where are we in the, I guess another way to put the question is that, is the industry mature enough? Is the ecosystem mature enough to deploy Open RAN commercially?
I think in small cells and 5G, and indeed small cells that incorporate 4G and 5G, we're seeing kind of, a narrowing down on the options. I mean, and one typical thing, for example, would be in 5G, that mid-band spectrum, band N77, sort of going from basically 3.4 to 4.2 gigahertz, and that incorporates a lot of spectrum that's been licensed around a lot of the world. It incorporates in the US both CBRS and C-band, and small cells, whether they're indoors or outdoors. Well, say it's classically indoors, 23 dBm power output radio head, 40, 4R. You're beginning to get things that are actually very common. And we found, when we've been doing interoperability with other equipment, that it's not a case of things that just don't work at all. You plug them together, and there may be, sometimes they have more than one way of doing the same thing, for example. But there's a bit of tweaking that goes on, but things are starting to basically work together. But if you then start going to other areas, and I think this is going to be down to operators, are they going to specify things which are kind of very unique to them, or are they going to go out into the market and think, yeah, this may not be quite exactly what I was wanting, but it's pretty close, and I'll just buy that.
Yeah, and I guess, it happens even if it's vertically integrated. If you see, like, the first deployments of 5G in South Korea were vertically integrated, and yet they had trouble that they had to resolve. So there is nothing special about this. However, if you work with someone, with other chipset vendors, and you all use the same interface, and it's interoperable, it doesn't mean that you have parity of performance. So how do you, and you mentioned test companies, is it something that you just like make sure you have the basics working together and then the testing will check performance, or is it going to be some certification, or is it going to be, how do you go from complying with the standard and providing same the performance you're looking for?
Yes, I mean, I think the one of the things in the Urban Alliance in their specifications, to an extent, they kind of sucked the intelligence out of the RAM and put it into the RIC. Now, I think actually that's got a long way to go before it becomes kind of something that's mature and robust and work in the field. But nevertheless, that's one level of performance of a network that you can kind of move out to somewhere else and allow people to innovate. I think that's one thing that some people kind of neglect, that there's performance of an individual radio and there's performance of a network as well. And that's something, a direction which Open RAN's moving in. And then you look at, you can performance-wise, there's the actual radio that's got, noise figure, all the rest of it. And there's that. But if you look at the sort of typical split 7.2, eCPRI open front haul, then a lot of the actual, the performance there is from the layer 1, which is very important performance, is all situated in the DU, the distributed unit. And that actually allows people who are developing DUs, DU hardware and DU software, to be able to differentiate performance, but with the same interface, that open front haul interface. And that is one of the keys to actually allow people who are specialists in particular areas to be able to provide improved performance without them having to get involved in everything else in the RAN.
Yeah, absolutely. So basically, you can by optimizing each step of the way, you can actually get a performance that is better than it's vertically integrated. So instead of having to pay for a penalty, you get a benefit in performance, even though you might not be there right now. That's the way we're going, I guess. Right?
Yes. Yes.
Absolutely. Yeah. Okay. So now. Whenever you talk about anything that is optimized, people say, well, is it going to be more expensive? What's your answer to that?
Yes, I mean, I'm going back to something I was saying earlier on. Optimized as in terms of smaller silicon area, it's fundamentally, less silicon area is fundamentally cheaper, but then it's all into who's making what profit margins. And that's about competition. So, I think to get the lowest price point, what you want is everyone doing something that was pretty optimized and competition between them. And then you'd have, a vendor would have, or an operator would have things to choose between. I think it's a fallacy to actually say, I'm going to go and buy some general purpose computer, and I'm going to do everything in software there. That's going to be cheaper. That general purpose computer, they're really expensive. They servers cost thousands of dollars. They've got actual individual processors on them that cost thousands of dollars. And in some cases, they're doing the same things as or less than, say, a $200 chip that's optimized for the purpose. And burning hundreds of watts instead of 10 watts. So that isn't actually optimized. It's just that idea people have that by buying something standard that's readily available, that's somehow cheaper than going out and finding something which is actually specifically designed for the purpose.
Yeah, and I think that it's really important to look at the operating cost, power consumption, for instance, because that's really that's most of the cost in any network. It's not the capex, although the capex is something you get hit, at the beginning. Yes. So you tend to pay more attention to it than sometimes than you should to the OpEx. Now, in closing, maybe you can tell us a little bit more sort of the big picture innovation. What is that, and from your experience, what is that you see that you're most excited about in terms of innovating within the Open RAN environment?
I mean, we're really excited because having being in companies in the 3G and WiMAX era and the 4G era and the 5G era. And it was far more of a struggle because you had to, one company or two companies, three coming together, producing a kind of just a one-off solution between you. It was very hard work. And then you may not get something that, was maybe specific for a particular operator. Everyone gets fixated. Oh, whoever it is, AT&T, Vodafone, or someone is, they want this. You get sucked into producing a, something that's optimized for them, and they buy, the small cells, say 100,000, and that's not very much, but you put a huge amount of effort in. The exciting thing, and Picocom, where we were formed to look at 5G small cells. That was our idea. And then we realized our real opportunity was Open RAN, and we can focus on what we do. We can partner with other companies, but not exclusively. And it's far more of an ecosystem, and we are working with across the globe with a variety of really exciting companies. I find that really exciting. So I think it's a little way to go yet, but I think the 5G era, because it incorporates 4G as well, the 5G era is really going to open up the possibilities, and I think Open RAN is just enabling that to happen.
So actually, very final question now. What is the next chapter in innovation from your viewpoint?
Oh, well, I think having got the basics there, with interfaces and Open RAN, you can do all sorts of things that, enhance performance. So things like distributed massive MIMO, looking ahead to 3GPP release 18. People looking at putting machine learning, AI, right into the RAN, so that things that are done algorithmic now, we'll be able to use AI techniques for as well. So that's something that's going forward, innovating. I think there's a lot of innovation. And one of my colleagues actually said, a few years ago, he thought everything interesting in wireless had been done, and he went off to do something else that wasn't wireless. But it's my colleague Doug Pulley, actually, he came back in and he realized, no, actually there are interesting things in wireless now. We were maybe in the 4G era, we maybe was looking a bit stale, but I think now things are becoming really exciting.
Yes, and I guess the more open, the more opportunities a lot of especially new players have.
Yes, and new players can come in and do you don't have to get $500 million in funding or something to be successful. You can come in and you can do some software components, and you can focus on that. It allows more players to come into the market.
Yeah, absolutely. Well, Peter, so much for talking to us today.
Thank you very much, Monica.
And for all of you, this is part of a report on the Open RAN ecosystem that you can download at senseofhealy.com. Thank you so much for your attention.